Okay, so we're still in the 2.3, so it's quite heavy, so I'm just trying to break it up as much as I can. But these are going to be some more important rules. So I think we were at what, 6? So the product rule might be number 7 if I'm counting correctly. But in that statement, of all the rules, you have to assume that f and g are both differentiable. So now the derivative with respect to x of a product of two functions. It is the first function times the derivative of the second function plus the second function times the derivative of the first. So sometimes you might see it, written the derivative with respect to x here, maybe just in terms of f and g, or they may, oh, I know, let's not do that. That's not proper. So in this case, you may see it shorthand, f times g with a prime. The first times derivative of the second plus the second times the derivative of the first. And if you want that to be written here, the product rule says that the derivative of a product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. And all of this stems from that limit definition, which is quite taxing. We're stating the properties, and we'll get to that in a moment. And so what would that look like? So let's take a look here. We have a derivative all over the derivative with respect to x. And now you have something like x squared plus a 3x times, and let's just say a negative x to the third minus a 2x squared plus 1. And in this case, you could treat this as f and this one as g. Now you could multiply all this quantity out and then take the derivative of each of those terms, but it's going to be a little bit more involved. So the first function we write as x squared plus a 3x times the derivative of the second function, which is going to be a negative 3x squared minus 4x plus the second function, which is going to be a minus x cubed minus 2x squared plus 1 times the derivative of the first function, which is 2x plus 3. And now let the fun begin, because in this case we have to multiply. So this equals, I'm just going to squeeze here because I'm going to need space, but I'm going to have to distribute, 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 distribute. So I'm going to get a negative 3x to the fourth minus a 4x to the third minus a 9x to the third minus a 12x squared. Then when I distribute here, here, and here, I'm going to get a minus 2x to the fourth minus 4x to the third plus 2x minus 3x cubed minus 6x squared plus 3. And now if we have like terms, we need to simplify them. So this would be, what is that? a minus 3, 4x to the fourth, minus 2. So this is a minus 5x to the fourth. I have a negative 4x cubed, a negative 4x cubed, a negative 3x cubed, a negative, shoot. You said, oh shoot, because I have an error. I always could find it. So when I, excuse me, oh, no. So this is x to the fourth, that's x to the third. Oh, here it is. So, well, actually when I multiplied these two, oh, that's why it came out that way. Oh, it's fine. So this again was a negative, what did I say? Negative 5x to the fourth minus an 11. Oh, I didn't take this one in consideration, was my problem. So that's a negative 13, negative 17. Now it looks like it's a negative 20. So getting this one to a negative 20 x to the third, a negative, so that's a negative 18 x squared plus 2x plus 3. So this derivative here will equal all of this, as long as my signs were done correctly. It's work. It is work. But again, right, it's part of the game. We're learning these new techniques to compute the first derivative. I am not going to go through this all right now, but I want you to see that in order for this derivative to, the product of the derivative to exist, it all stems from the limit definition. And then you will have to do some algebra manipulation here, algebraic manipulation here, do some factoring to get that. And I'll talk about it, but just not right now due to time constraints. Now, so what was that? 7? I think this will be rule number 8. And this will get into the quotient, derivative of the quotient of two functions that are differentiable. And so you see that that would be g prime, misspoke, that would be g times the derivative of f minus f times the derivative of g all over g squared. Now, a lot of times that's taxing. So if you think of f as your loaf, if you think of f of x as your high function and g as your low function, so oftentimes we could write this as, let's say, f divided by g prime is going to be your low function times the derivative of your high function minus your high function times the derivative of your low function all over your low function squared. That's the shorthand version. But to see it written out here, right, the derivative of the quotient is the denominator, which is your low function, times the derivative of the numerator, which is your high function, minus the numerator, which is your high function, times the derivative of your denominator, which is your low function, all divided by the square of the denominator, which is your square of your low function. So it's a little bit of work, right? 8 rules, and we still have 6 trig functions at bat. And we're going to take a look at a couple of these examples together. So I'm just going through these rules because we have quite a bit. And so again, a lengthy proof for this definition. And then I kind of just want to illustrate the difference here. Now they illustrate n is a positive integer, where was illustrating now what happens if you have a negative exponent. So again, you notice that the exponent becomes the coefficient, and you still reduce your exponent by 1. But if it's a minus a positive number, then you can get a negative exponent. And so it is a more generalized power rule. But then they say, oh, well, let's scratch that, and let's just say now that n is any real number. Again, you bring out the coefficient, the exponent to the coefficient, and you reduce that by 1. And so now, the reason why it changes is because the proof changes. So if you want to find the derivative with respect to x, and you have something like x to the 1/3 power, then that's going to be a 1/3 x to the 1/3 minus 1. So therefore you get a 1/3. This is x to the 1/3 minus 3 over 3, which is going to be a 1/3 x to the minus 2/3 power. And the golden rule, or many golden rules, is we typically simplify to have positive exponents. So you'll have 1 all over 3 x to the 2/3 power. So the rule is the same. The difference is that the exponent is now changing. And so this is a modified, so what do we call the quotient? So the quotient was at 8. So we will just keep this one at 9. So there are 9 properties all in 2.3. And then there are the trig functions, and then it's the chain rule, and then implicit differentiation, all in this chapter. And again, the derivative represents few things. 1, the slope of a tangent line at any given point. 2, the instantaneous rate of change. 3, the rate of change. 4, the growth rate.